What if I told you that the next time humans set foot on the moon, it might not be Americans who get there first? There is a race underway right now, one that most people don't fully understand, one that the mainstream media barely covers, and one whose outcome will define the balance of power in space for the next century. By the end of this video, you will know exactly who is ahead, what is truly at stake, and why the decisions being made right now could change everything we thought we knew about humanity's future beyond Earth. Stay with me, because this story is far bigger than a rocket launch. Let's start with something NASA quietly changed, something that barely made headlines, but that fundamentally rewrote the entire roadmap back to the moon. The original Artemis plan was almost shockingly simple. Launch Artemis 2, fly 4 astronauts around the moon, and come straight back home. No landing, just a test of the capsule and the crew. Then, on Artemis 3, go directly to the surface. That was it. No rehearsal of the landing, no dry run with the lander, no safety net whatsoever. The plan was essentially, show up at the moon, hope the landing system works, and figure it out from there. Now, to be fair, NASA has landed people on the moon before under extreme pressure and with far less technology than we have today. But that was a different era, an era where the entire nation was mobilized, where budgets were essentially unlimited, and where the risks were accepted by a society that genuinely believed the mission was worth dying for. Today, the calculus is different, and the consequences of failure, political, financial, and human, are far more severe. So the old plan is gone. And honestly, once you understand what replaced it, you will realize that what NASA is now attempting is not just more cautious. It is dramatically more ambitious, more complex, and if it succeeds, far more impressive than anything the original plan could have delivered. Before we can talk about what comes next, we need to understand what Artemis 2 actually accomplished. Because it was not just a joyride around the moon. Artemis 2 sent 4 astronauts aboard the Orion capsule on a free return trajectory around the moon. No orbit, no landing, just a long looping arc that brought them close enough to see the lunar surface in detail and then swung them back toward Earth. The mission lasted roughly 10 days and proved something critical. The Orion capsule works, the life support works, the thermal protection system, which must survive temperatures of thousands of degrees during re-entry, works. The crew can function in deep space, far beyond the protection of Earth's magnetic field, for an extended period. But there was something else tested on Artemis 2 that most people overlook entirely. Something that will become absolutely essential for what comes next. During the mission, pilot Victor Glover performed a mock docking exercise. He took manual control of the Orion capsule and carefully steered it toward the spent upper stage of its own rocket, using it as a target to practice the approach and alignment needed to dock with another spacecraft. It sounds routine. It is anything but, because on Artemis 3, Victor Glover and his crew will need to dock with a lander they have never physically touched before. In orbit, with no margin for error. That practice run mattered. Now, here is what the new Artemis 3 actually looks like, and I want you to understand the full scale of what is being planned here, because when you see it laid out from beginning to end, it is genuinely staggering. This is not a single rocket launch. This is a coordinated multi-vehicle space operation, involving potentially 5 or 6 separate launches, 2 different companies, orbital refueling maneuvers that have never been attempted before, and a crew of astronauts who will spend up to 3 weeks living inside a prototype lander, all without ever leaving Earth orbit. It begins before the astronauts even get off the ground. The first things to launch are the lunar landers themselves. SpaceX's Lunar Starship and Blue Origin's Blue Moon must both reach low Earth orbit and be ready and waiting before Orion ever leaves the launch pad. And this is where the first massive challenge emerges. Both of these landers are enormous. Lunar Starship is effectively a skyscraper turned on its side, a vehicle so large that it dwarfs anything previously built for lunar missions. Blue Moon is similarly massive by any historical comparison, and that size creates a fundamental problem. They consume fuel at a rate so extreme that simply getting from Earth orbit to the moon and back would require more propellant than they can physically carry at launch. If they arrive at the moon already running low, the astronauts who board them will have no way home. The solution is orbital refueling, and it has never been successfully done before with vehicles at this scale. SpaceX will launch a second Starship, operating purely as a fuel tanker to rendezvous with lunar Starship in orbit and transfer propellant directly from one vehicle to the other, while both are moving at thousands of miles per hour above the Earth. Blue Origin will send a separate propellant transport vehicle to do the same for Blue Moon. 2 orbital refueling demonstrations simultaneously. For the first time in human spaceflight history, the engineering challenge alone is enough to fill an entire documentary. With both landers refueled and waiting in orbit, the SLS rocket finally launches, carrying the Orion capsule and its crew. But they are not going to the moon. Not yet. They have a rendezvous to make first. Approaching a massive autonomous spacecraft in low Earth orbit, one that cannot move toward you, one that you must match speed and trajectory with millimeter precision, is one of the most technically demanding tasks in human spaceflight. The lander will be waiting, the crew will be approaching, and the pilot will have one shot to get it right. In one scenario, Orion approaches the Blue Moon from the side. The docking port is located on the crew cabin at the bottom of the lander, below several stories of fuel tanks stacked above. The connection is made, the hatch is open, and the crew floats through into the habitation module. It is not a lavish space, but when you put it next to the old Apollo lunar module, a craft so cramped that astronauts could barely turn around, the Blue Moon offers a meaningful improvement. There is room to move, room to work, room to think. In the other scenario, the crew approaches lunar Starship. The docking port on Starship is located at the very nose of the vehicle, at the top. When the hatch is open and the crew floats through, they find themselves descending into a space 9 meters wide and several meters tall. It is an almost absurd amount of room by spacecraft standards. The flight deck is spacious. There is room for equipment, for testing, for the crew to spread out and actually work efficiently. Coming from the relatively tight confines of Orion, stepping into Starship must feel like walking into a cathedral. Once inside either lander, the crew gets to work. And this is where the real value of the new Artemis 3 plan becomes clear, because what they are doing inside that lander is not a formality. It is a comprehensive, methodical stress test of a vehicle that will eventually carry human beings to the surface of the moon. The crew will evaluate the life support systems, the ones that manage air quality, temperature, humidity, and carbon dioxide levels. They will test the propulsion systems, running through throttle sequences and checking response times. They will push the communication systems, testing bandwidth, latency, and reliability across various orbital positions. They will examine the power systems, the solar panels, the batteries, the distribution network that keeps everything running. But they will not just sit inside and run diagnostics. They will undock from Orion entirely, fly the lander under manual control through open space, and then redock, proving that the vehicle can operate independently and that a human pilot can manage it without Orion as a safety anchor. This is the kind of testing that separates a successful mission from a disaster. Finding a fault in Earth orbit means you can fix it. Finding a fault while descending toward the moon means you cannot. And then there is one more test, one that is easy to overlook, but that may be the most symbolically powerful moment of the entire mission. Inside the lander's airlock, the astronauts will don their Axiom Space lunar suits for the first time in the actual vacuum of space. These suits are unlike anything NASA has used before. They are not derived from the ISS suits. They are not updated versions of the Apollo suits. They are an entirely new design, engineered from the ground up for the specific conditions of the lunar surface, with far greater mobility and agility than any suit that came before. They have been tested underwater, in simulated microgravity environments, in pressure chambers, but no test on Earth can fully replicate what happens when the suit is exposed to the hard vacuum of space for the first time. This will be that moment. And if the suits perform, if the seals hold, and the pressure holds, and the joints move the way they were designed to, it will be one of the quietest and most important milestones of the entire Artemis program. But while the astronauts prepare for orbit and NASA finalizes its mission timeline, there is another battle being fought right here on Earth, on launch pads in Texas and on the beaches of Florida. In May 2026, SpaceX is scheduled to conduct the first flight of Starship version 3. Not a prototype, not an iterative test vehicle. SpaceX believes this is the finished product, the first Starship that is ready, in structural and propulsion terms, to fly people to the moon. The vehicle will launch from a brand new launch pad system at Starbase, Texas, incorporating all of the lessons SpaceX has learned from previous test flights. If it performs as expected, SpaceX will then have approximately 1 year to build the interior, the life support systems, the crew quarters, the displays and controls and emergency systems needed to make a 90-meter rocket into a livable space for human beings. 1 year for what amounts to building a small space station inside a rocket. It sounds impossible. For SpaceX, it is just another deadline. Meanwhile, Blue Origin has its own historic milestone approaching. The Blue Moon Mark 1, a smaller, cargo-only version of the human landing system, scheduled for a test flight in May as well. This vehicle is not designed to carry people. It is designed to carry medium-sized cargo payloads to the lunar surface, and that is exactly what Blue Origin intends to demonstrate. Fly to the moon, descend through the final kilometers of approach, and land safely on the surface. No crew, no drama, just a clean, successful touchdown on another world. If they pull it off, the implications are enormous. Blue Origin has long been considered the underdog in this competition, a company with deep pockets, but a slower development pace than SpaceX. A successful lunar landing would transform the narrative overnight. It would prove that Blue Moon is not a concept, it is a vehicle, and it works. Assume everything works. Assume Artemis 3 is a success. Both landers are tested in Earth orbit. Both crews come home safely. The data is analyzed, the fixes are made. What comes next? First, an uncrewed lunar landing, what some are informally calling Artemis 3.5. One of the two landers, whichever is declared the more ready, will be sent to the moon autonomously. No crew, just the vehicle, the software, and the landing system operating without human input. This is the final gate. You can validate a lander in Earth orbit all you want, but until it actually descends through the final kilometers above the lunar surface, slows itself from orbital velocity to nearly zero, and touches down safely on terrain that no probe has ever mapped at the resolution needed for a crewed landing, you do not truly know if it works. Only one lander will land on the moon first, and only then can a winner be declared. But even that is not the end. It is barely the beginning, because NASA has set an almost brutally aggressive timeline. Artemis 4, the first actual crewed moon landing since 1972, must happen within 1 year of Artemis 3. 1 year. That means the winning company must be capable of not just building a lander that works. It must be capable of building them repeatedly, quickly, and reliably. The manufacturing pace required is unlike anything the private space industry has ever sustained. It is a test not just of engineering, but of industrial capacity, supply chains, workforce, and willpower. So, remember what I asked you at the very beginning of this video. Will it actually be Americans who get to the moon first? The honest answer is, it depends on what happens in the next 12 to 24 months. And it depends on something that has nothing to do with rocket engines or lunar suits or orbital refueling. China has a lunar program, a serious one. China has stated publicly that it intends to land astronauts on the moon before 2030. They have the rockets, they have the landers in development, they have the political will and the national resources to pursue this goal with a focus that democratic governments often struggle to match. And they are not going to the moon to plant a flag and come home. They are going to establish infrastructure to begin the process of building a permanent presence on the lunar surface. The moon is not just a destination, it is a resource. Water ice locked in permanently shadowed craters near the poles can be converted into rocket fuel, turning the moon into a refueling depot for missions deeper into the solar system. Whoever controls access to that water controls the economics of deep space exploration. Whoever establishes infrastructure at the lunar South Pole first will have an enormous strategic and logistical advantage over everyone who comes after. This is why NASA is in a hurry. This is why the timeline for Artemis 3 and Artemis 4 is so aggressive. This is why two companies are being tested simultaneously, rather than one at a time. Because this is not a science project. It is not a prestige exercise. It is a competition. One with consequences that will echo for decades, possibly centuries. America is going back to the moon. The technology is ready, or nearly so. The plan is in place. The astronauts are training. The rockets are being built. The only question left is whether all of it comes together in time, and whether, when the moment arrives, It is an American bootprint that marks the next chapter of human history on the lunar surface. The clock is running, and no one is slowing down.